Okay, let's talk about what we do if we encounter a square root equation, or one or two things we can do when we encounter square root equations, and maybe even cube root. We'll get to that, but let's just start with one here. The square root, let's say, of 5x plus 1 equals 4. Square root of 5x plus 1 equaling 4. Perhaps we could eyeball that one in, but let's talk about a technique that will allow us to solve, for the most part, any square root of equation. Of course, the problem here is we've got the x we want to solve for, and it's underneath the square root. And so the idea is going to be to get rid of the square root if we can. And here's what we're going to do. Let me just show you what we do. We square both sides. Doing the same thing to both sides. And I'm doing to both sides, squaring both sides. Now, why do I do that? Well, let's come over here to the side for just a second. Let's say I had the square root of 7, and I squared it. So it's like what we've got there on the left. The square root of 7 squared, well, if we just go through it here, doesn't that mean the square root of 7 twice, times multiplied together twice, which gives us the square root of 49, doesn't it? Which the square root of 49 is 7. Right? All right, well, maybe another one here. What if I did the square root of 10 and I squared it? Well, you get the square root of 10 times square root of 10, which is square root of 100, which that's 10 also. And so you might observe there a bit of a pattern. What is happening when I'm squaring these square roots? Basically, the square root and the square cancel out, don't they? Yeah, they're inverse operations. The square root and square are inverse operations, and so they cancel one another out. So when I square a square root, that just leaves me what's inside there. Okay, same thing happened here. The square root and the square basically canceled out, and so I wound up with 10. So, and it works. The way we'll use it is, of course, it works for anything in here. You know, if I had 5y squared minus 9, well, if I take that square root and square it, yeah. What I wind up with is just whatever's inside, okay? So, back to our problem over here. Do you see why then I would square both sides here? Because what happens over here on the left? The square and the square root cancel out, and that just leaves me 5x plus 1 equal, now this side, it's 4 squared, and so what happens there? Well, you square 4 and it's 16, yeah. So we wind up starting with the square root equation, but squaring both sides, we wind up with a non-square root equation. That's just a linear equation now. Just solve it for x, right? Subtract 1 and divide by 5. X equal 3. Okay, yes, it checks out. Yeah. Now that does bring up a point. They're just like the rational equations we talked about before. What can happen is sometimes this may not work. It's for a different reason than the rationals, but yeah, it's a real good idea here to check to make sure that it works. In other words, take this and plug it in and see that it works, because it doesn't always, it's not always guaranteed to work, but as she said there, plug it in and it works, doesn't it? 5 times 3 plus 1, that gives you 16, and square root you get 4. Okay? All right. Now it works on either side. If you've got 13 equals the square root of 8 minus 2x, that's going to work the same way. It's got a square root on the right, so if I square both sides there, of course 13 squared is 169 on the left, but the square root and the square on the right cancel out, and so I wind up with 8 minus 2x only on the right side, so I subtract the 8. That gives me 161 equals negative 2x. Divide by negative 2. Whatever you want to say that is, negative 80.5, or you can leave it as a fraction, I guess, but plug it in and it checks out, I do believe. Just a little quick check here just to make sure everything squares out there. Yeah, I think what you get here is the square root of 8, and that'll be plus 161, which is the square root of 169, which is 13. Okay? So it checks out. All right. So that's the basic idea behind solving a square root equation. Let's talk about a couple of others with another twist or two on it. Square root of x minus 5, and then the plus 4 equal 10. The plus 4 on the outside of the square root, on the left there. Okay? Well, we've talked about this sort of thing before. You know, we've got these techniques, like on the absolute value. We had a technique there, but this is similar to it. What do you think we've got to do here, first of all? I got to move the 4 over. Yeah. Before I square both sides on this one, I've got to get the square root by itself. First of all, get the square root by itself. First of all, for this technique to work, yeah, you need a square root by itself. So, yeah, subtract the 4 over from both sides, and we get the square root of x minus 5 equals 6. By subtracting the 4, then I'm good to go square both sides. Square root and the square cancel, so you have x minus 5. 6 squared is 36. Now just have a nice little equation here. Add the 5. X is 41. And if I plug that in to check it, just to make sure, square root of, that'd be 41 minus 5 plus 4. Does that equal 10? I believe so, because that'd be the square root of 36. Square root of 36 is 6. Yeah, that checks out. Okay. All right. Two square root 5k minus 1 plus 15 equals 3. 2 square root 5k minus 1 plus 15 equals 3. All right, so same deal there, right? I need the square root by itself. So let's get that done. I'm going to subtract the 15, so I get 2 square root of 5k minus 1. 15's out. Negative 12 equal negative 12. And I can also on this one go ahead and can I divide by 2? Yeah. So I wind up with the square root of 5k minus 1 equals negative 6. Square both sides. Square root and the square cancel, so I just have 5k minus 1. Negative 6 squared is positive 36. And so then if I add 1, I get 5k equal 37. Divide by 5. And so k is 37 over 5. However, this is a good one here. We should check. We go through the check here. 2 times square root of 5 times 37 over 5 minus 1 plus 15 equals 3. Does that check out? That's going to be 2 times the square root, and then actually there the 5's will cancel, so it'll be just 37 minus 1 plus 15. It's 2 times the square root of 36 plus 15. Well, that's 2 times 6, 12, plus 15 gives you 27. Uh-oh. Doesn't check out there. Yeah, sometimes the answer you get there, various reasons, doesn't work. That one, in this case, doesn't work. So what's the deal there? No other answer we could possibly get out of that, so what's the set we would say here? Solution-wise, no solution yet. Okay. All right. Let me show you another one here. The square root of 5x minus 14 equals x minus 2. Yeah, this one has another small detail about it. All right, well, no problem starting out here anyway, because we've got a square root on one side by itself, so what's our first step? Let's square both sides. On this side, the square root and the square cancel out, so you get 5x minus 14. Now, on the right, though, this is why I wanted to mention this one. What do I do on the right? Have x minus 2 squared. Do I just square the x and square the 2? Now, there's a little more to this one than just squaring the x and squaring the 2. Since it's a binomial squared, best thing to do, remember that means x minus 2 twice. So write it twice and FOIL. Yes. Yeah, there's a little foiling involved here on the right side on this one. So you've got to FOIL it out. X times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is minus 2x. And then minus 2 times minus 2 is positive 4. So wind up with 5x minus 14 equals x squared. Then I minus 4x plus 4 on the right. Which brings up the next point. And that is, how am I going to solve that one? I need to do a little factoring, don't I? This is an x squared equation. And so, unlike the previous one there, what do I want to do here first or next? I want to make what? What do I need to do here? Need one side 0, don't I? Yeah, for an x squared equation of this type here, yeah, you need one side to be 0 because I'm going to use factoring. And on factoring, you got to use one side 0. So let's take these two terms over to there. So that'd be minus the 5x and add the 14. Get us 0 over here on the left. With me on that? 0 equals x squared minus 9x plus 18. So that would make then this factorable. Factor our x squared minus 9x plus 18. That'd be x and x. And 18 with minus 9 in the middle. 6 and 3. Both minus. Do a minus 6 and minus 3. That'd give me the minus 9 in the middle. Okay? All right, so then we set those each individually equal to 0. X minus 6 equals 0, x minus 3 equals 0, then add the 6, and x is 6, add 3, and x is 3. Be sure both of those check out. If I plug in 6, does that work? That would give me the square root of 30 minus 14 equals 6 minus 2. Is that right? That's the square root of 16 equal 4. Yeah, that's true. So it works. 3, that'd be the square root of 15 minus 14 equals 3 minus 2. Checking it out, that's the square root of 1 equals 1. Yeah, that's true too. Okay. So in this case, we've got two solutions. 6 works, and 3 does as well. How about that?